Hello, good day. We're going to talk about the voltage divider bias, which is the continuation of our topic, the CE emitter bias configuration. So, unlike the emitter bias configuration, so in the voltage divider, we have R1 and R2, and this is the R equivalent circuit of the voltage divider bias. As you can see, there is a bypass capacitor CE. So that is why R1 and R2, this will be parallel to the beta RE, and there's an output resistance which is R sub O and the resistor RC. So since there's a bypass capacitor, the R sub E is omitted. So like what we did in our emitters bias configuration, we're going to calculate the voltage gain. These are the important parameters of this amplifier. Voltage gain, the input impedance in the output impedance. So to calculate the input impedance, so Zi, so as you can see in the input side, it is just equal to R1 parallel with R2 and then parallel with beta Re. So this is the input impedance of the circuit. So the voltage gain, the output voltage, output impedance is it is just equal to, as you can see in the output side, R sub O is just parallel with the RC. No? But if RO, if we can approximate the formula where if RO is 10 times greater than R sub C, so we can approximate that ZO is just equal to RC. So if R sub O is 10 times greater times RC, so we can assume that the output impedance is just equal to the collector resistance. So in order to calculate the voltage gain, as you can see in the output side, the output voltage is just equal to this. So this is the total current. So since the current is so in the counterclockwise direction, so this is negative IB times the total resistance, which is RC parallel with RO. And then in the input side, as you can see, uh, IB, I sub B is equal to the voltage gain, the voltage input divided by beta RE. So this is VI. So since parallel naman so na I sub B and then the resistance which is beta RE. So substitute this one in this formula. So V out is equal to negative beta times VI divided by beta RE times RC parallel with RC parallel with R sub O. So as you can see, cancel in beta. Therefore, negative VI divided by RE times RC parallel with RO. So therefore, the voltage gain V over VI is equal to negative RC RO parallel with RE. So this is equal to voltage gain is equal to negative RC parallel RO divided by RE. But same with the output impedance. So if RO is 10 times greater than RC, so therefore we can approximate the formula by neglecting R sub O. So therefore this is the voltage gain. So you can use either this formula or you can use either this kanina formula to be more exact. So this is the input impedance formula, this is the output, and this is the voltage gain. So as you can see, the emitter capacitor is bypass. Bypass ng voltage divider. So that's why we omit R sub E. So let's have an example. This one. So we have a voltage divider configuration where we have this is 56 kilo ohms, this is 6.8 kilo ohms, 8.2 kilo ohms, and 1.5 kilo ohms. Determine R sub E, ZI, the output voltage, output impedance, the voltage gain, and the parameter of parts B if we change R sub O equal to 50 kilo ohms. So we should calculate first R sub E, no, by calculating I sub E. So in this formula, so this will be, we're gonna find RTH and then ETH, and also to calculate the IB, and then if we calculate IB, we can get the I sub E. So this will be, so to find RTH, so this is just equal to the parallel running duha, no? This is will be 56 kilo ohms times 8.2k divided by 56k plus 8.2 kilo ohms. So RTH is equal to, so use your calculator, 6 is 8.2 divide 56 by 56 plus 8.2. So therefore this is 7152.65 ohms, or this is 7.152 kilo ohms RTH. So ETH is equal to, it's just equal to 22 times this one. This is ETH is, this is 8.2 kilo ohms divided by 8.2 kilo ohms plus 56 kilo ohms. So ETH is equal to, so by using the calculator, 22 times 8.2k by 8.2k plus 56. So therefore ETH is equal to 2.81 volts. So you have now RTH and ETH by Thevenin's equivalent. So we can now calculate the IB. We're equal to, this is ETH minus zero point 0.7 minus IE times uh, this is, so this will be ATH minus zero point 0.7 times minus, so ETH is equal to minus, so this will be the Thevenin's equivalent, IB times RTH minus the zero point 0.7 minus IE R sub E equal to 0. So ETH is equal to 2.81 minus IB. So this is capital, so since DC analysis, times 7.152 kilo ohms minus zero point 0.7 minus IE times 1.5 kilo ohms equal to 0. So therefore, so as you can see, we want to calculate IE and IB, and IE is just equal to beta plus 1 times IB. So this is the formula. So in terms of IB, so this will be IB is equal to IE divided by beta plus 1. So substitute na to ni Dra. So this therefore 2.81 minus IE divided by beta is 91 times 7.152 kilo ohms, 0.7, and then this is IE, this minus times 1.5 kilo ohms equal to 0. We want to find I sub E, so therefore transfer these two voltages in the this current, transfer on the side, right side. So this is 2.81 minus 0.7 equal to this is IE. So since common ang IE, so therefore this will be 7.152 kilo ohms divided by 91 plus 1.5 kilo ohms. So in terms of IE, so divide both sides by this equivalent. So 2.81 minus 0.7 divided by 7.152 kilo ohms divided 91 plus 1.5 kilo ohms. So IE is equal to, so you can use your calculator, 2.81 minus 0.7 by 91 plus 1.5k. So therefore this is 1.34. This is milliamps. So you have IE, emitter current of 1.34 milliamps. So you have now IE, you can now calculate letter A. So R sub E is equal to 26 millivolts divided by I sub E. So 26 millivolts divided by 1.34 milliamps. So you have now R sub E be equal to 1.34 milliamps. So this is 19.4 ohms. You have 19.4 ohms. So what we did was the exact analysis, no? So this is the exact analysis by using the Thevenin's equivalent. So we have now RE, we can now calculate letter B, which is the input impedance, where ang RO is equal to infinite ohms. So as you can see, since this is infinite, so this is 10 times greater than the RC. So we can use the formula ZI equal to, we can use the formula ZI equal to R1 parallel R2 and parallel with beta RE. So therefore R1 is equal to 56k parallel with 8.2k, and then parallel with 90 times 19.4. So the result will be, so use your calcio, parallel. So this will be 1 over 56k plus 1 over 90 times 19.4. So therefore the input impedance is 1.403 kilo ohms. So that is 1.403 kilo ohms. The output impedance is, so RO is infinite man, so this is RO is equal to infinity ohms. So we can use Z out is just equal to RC. So Z out is equal to RC. So this is 6.8 kilo ohms. Letter D is voltage gain. So voltage gain is equal to negative RC over RO, RE. rather. So this is negative 6.8 kilo ohms divided by 19.4. So voltage gain is 6.8 divided 19.4. This is negative 350.51. So you have a voltage gain of negative 350.51 in a voltage divider. So letter A, as you can see, different output are sabo. So compare natin na siya. So letter B, let's ano to sa letter C, where if RO is equal to 50 kilo ohms. So what will be the um, effect sa atong parameters? So if R is equal to 50K, so therefore Z out now is equal to RC parallel with RO, which is 6.8K parallel with 50 kilo ohms. So Z out is equal to 1 over 6.8K plus so this is 5.99 kilo ohms. So how about the voltage gain? So this is RC parallel with R sub O divide RE. This is negative. So therefore this is 6.8 divided by 50K divided by 19.4. So this is negative. So voltage gain is equal to um, divide 19.4 308.8 negative. So as you can see, we have a we have a comparison with we neglect the RO and with the value of R sub O equal to 50K. So as you can see, there's a slight difference. So if we neglect the R sub O, so we've got an output impedance of 6.8, but with the R sub O equal to 50K, so name siyang almost 6 kilo ohms. And then for the voltage gain, negative 350. If we neglect R sub O, negative 50 ang voltage gain. And if we include the R sub O, which is equal to 50 kilo ohms, the voltage gain is equal to negative 308.8. So let's answer voltage divider example, but this time it will be unbypassed. So there's no capacitor parallel with the emitter resistor. So letter A, calculate R sub E, ZI, ZO, and the voltage gain. So as you can see, if there's no bypass capacitor, so this will be the same with the emitter bias configuration, where the RE model is this one. As you can see, we have the R sub E, capital R sub E, and then we have now R1 and R2, so the equivalent circuit. So as you can see, to calculate R sub E, it will be the same with our previous example, which is this one. So this was our previous example where R sub E will be the same with this example. So since we have the same parameters, R1, R2, RE, and RC, so therefore the R sub E will be the same with our previous example. R sub E is equal to, which is 19.4, which is this one. No, this was calculated in the previous example, okay, with the bypass capacitor. So therefore R sub E is 19.4 ohms. So we're gonna use 19.4 ohms, but with the input impedance, it will be this different since nanay R sub B, capital R sub B. So therefore, this will be R sub 1 parallel R sub 2, and then this time it will be parallel with the ZB, where ZB is equal to, this will be, the formula will be equal to beta times R sub E, small letter R sub E, and the capital R sub E. So this was discussed during our um, emitter bias configuration. And then this will be, so since beta is 90, so 90 is equal to 90 times 19.4 plus R sub B is 1.5K. So therefore ZB is equal to, ZB is 90 times 19.4 plus 1.5K. So therefore this will be, so therefore this will be 136.75 kiloohms. And then the input impedance now is now equal to 56 kiloohms parallel with 8.2 kiloohms parallel with 136.75 kiloohms. So therefore the input impedance is 1 over 1 plus 1 over 8.2K 1 over 136.75 kiloohms. So therefore the input impedance is 6.79 kiloohms. So this is now our ZI. So next, the voltage, the output impedance Z out. So I think it would be the same with the previous answer, no? This one. So therefore Z out is the same with, is just equal to 5 point. This is RC parallel R sub O. Oh, by the way, if it is unbypassed, so it is better to neglect the effect of R sub O, because if you include the effect of the R sub O, it will complicate our solution. It will, the formulas will be longer compare if we neglect, but the difference are just a little bit compare with the approximate and the exact computation of the unbypassed voltage divider. So in this time, or in this example, we're gonna neglect the effect of R sub O. So therefore Z out is just equal to RC. So Z out, output impedance is just equal to 6.8 kiloohms. And then for the voltage divider, for the voltage gain, just equal to, so in our previous topic, which is the emitter bias configuration, so it's just equal to, they will have the same formula, negative RC divided by small r sub e, this is the capital R sub e. So therefore this will be negative 6.8 kiloohms divided by 19.4 plus 1.5 kiloohms. So therefore voltage gain equal to 19.4 plus 1.5. So therefore this will be negative 4.475. So we have now a voltage gain of negative 4.475, output impedance of 6.8 kiloohms, and input impedance of 6.79 kiloohms. So as you can see, if you compare the unbypassed and the bypass capacitor, so as you can see, this is the These are the parameters we've calculated. For the bypass voltage divider, we have 1.403 kilo ohms as an input impedance, and the unbypassed is 6.79 kilo ohms. So as you can see, for an amplifier, for to improve its quality, for an ideal amplifier, the input impedance of an amplifier, it should be greater. It should be um, more input impedance so that the quality of the amplifier is uh, in its standard. As you can see, in a bypass capacitor, so if you compare the input impedances to the bypass and unbypass, the unbypass has a greater input impedance compared to the bypass voltage divider. But as you can see, the effect of the voltage gain is reduced in the unbypassed voltage divider. So as you can see, if you look at the input impedance, the unbypassed is greater but smaller voltage gain. So advantages sa input impedance and sa bypass, advantages sa voltage gain. So in order to complement each configuration, so sometimes we're gonna use these two configuration connected in cascade. So in order to complement its disadvantages, no, to have more input impedance as well as higher voltage gain. So these are the a comparison between the bypass and the unbypass voltage divider configuration.